To it. So welcome back. I hope you had a nice break and are ready to take in some short, sharp lightning talks. My name is Megan Guidry. I work for NeSI and I will be facilitating the lightning talk session today. We have 4 speakers here who will each give a 5-minute presentation followed by a short Q&A session. Please post any questions you have for the presenters in the live Q&A box, which is on the right side of your screen. And as you know by now, the portal does a fantastic job keeping us on time by cutting us off at the end time of each session. So we will likely only have time for 1 or 2 questions per presentation. So remember to reach out to our presenters in the meeting hub if we don't get to your question in the session today. So our first presenter is Bruno Kinoshita with Cylc User Interface Scalability. Welcome, Bruno.
Oh, hello, Megan. Hello, everyone. Thanks for having me. I start sharing my screen. Just make sure that I choose the right one. Is it okay, Megan?
Yep, I can see your screen just fine.
Perfect. So hi, everyone. I'm Bruno. I work with NIWA on Cylc. Yesterday's keynote of Hillary Oliver was about the scalability of the workflow, which is in one end of the system. I'm talking about the user interface scalability today. And it's a little bit different. This definition is quite good. It talks about when you add more features to your product, in this case, a web application. You want to support scalability in the sense that you want to have a good experience for the user, not so much about the performance, which if you watch the keynote yesterday, you may imagine that Cylc workflows could have thousands of tasks. You can have a good enough performance that you can send all the thousand of tasks to the browser, but we still want to be able to display that in a way that gives a good experience to the user. So that's the context for the problem that we have. As Hillary also pointed yesterday, Cylc 8 is replacing Cylc 7, and it's moving from Python 2 to Python 3. We lost the PyGTK GUI, so now we are moving to a Cylc 8 JavaScript interface, web interface that runs with on top of Jupyter Hub. So there are 3 topics that I will try to squeeze in these 5 minutes. Hopefully the 2 first ones would be easy to do, and the last one, if I have time, I will explain. The first one is how to maintain the good user experience in the browser. So let's jump on that one. A few problems that we have when you move to the browser are that in the desktop, you have access to the hardware resources and to the operating system a little bit easier than in the browser. And also from a security point of view, you can access files, you can check the user account. But in the browser, you have several protocols and you have sandboxing browser extensions, which also hinder the performance. And as you see in the next slide, there is a screenshot of Cylc 7, which is a multiple window interface. But in the browser, you normally have just one window or one tab. You don't want to have multiple pop-ups. So we also have that challenge. And we have a few more about performance and the document object model that I'll talk more if I have the time. This is a screenshot of Cylc 7. You can see here that there are several windows open. The top left corner shows the most important one, or the main one, which displays on the left side the tree with the cycle points, families, and tasks. On the right part of that screen, you see a graph that is similar to the screenshots that you probably saw yesterday in Hillary's talk. So what have you done about that? We are reducing the complexity. We have an excellent design sketch done by Oliver Sanders, who was here on secondment from the UK Met Office, working in Wellington for a while. He did this design sketch, and it basically gets everything that we had in Cylc 7 and tries to port that to the web interface in a summarized way, in a way that works well. We also have components that we started to build in this design sketch that we can reuse. And instead of modifying the document object model of the browser, which is basically, if you imagine, is a tree in the browser here, this part that I selected is one element inside all the elements. And there is a lot of challenges when you start moving and changing these elements. So with Vue.js, we work on a virtual DOM, very similar to Pandas or Dask, when instead of computing everything, you create an abstraction and then you in this virtual DOM. And when you apply that to the actual DOM, Vue.js does some optimizations. It helps with performance, but also gives a better experience. And Vue.js is built with components. So we are putting everything together on our benefit for Cylc 8. We also have a few defaults in the application so that if you have 1,000 tasks, you don't display the 1,000 tasks in the viewport of the user. Instead, we have scroll bars. We are working with the possibility of having lazy loading of data, of having a virtual scroller, but we also have a few techniques of web development that you can apply. And we also have reactivity of Vue, which is similar to R Shiny. If anyone has used that, you just have a little bit more of control. So that's what we are doing about the problem that we had for browser versus desktop. And this is what it looks like. On the left side, you see, we call that the GScan, which contains the user and the environment, a few links, and the workflows. At the moment, on that screenshot, there was just the families2 workflow, which is one that I use for testing. On the right-hand side, you should see at the top the name of the workflow, a button to add more views, and these views, these tabs, they are done with a component. Let me move to a GIF, an interactive preview. These tabs, they are done with this exact same library of Jupyter Lab. For users that are familiar with Jupyter Lab, they should immediately recognize and be able to use the interface. And as you see, we are trying to display as many tasks and families, etc., as we can in the interface. And
About
it's
30
not so
seconds left,
different.
Bruno.
Sure. And it's not so different than in Cylc 7. And this is the mobile interface too that we have. So we should be able to display that for mobile users as well. And finally, we also have a problem with the data of the workflow. And for that, we are using GraphQL, which David Sutherland here in Wellington is the guru behind that. I won't have much more time. I'll just leave here the query of GraphQL running. This is what powers the user interface of Cylc 8. In the past, we had a REST interface, and this can be a whole talk about GraphQL, but we won't have time. So I will leave the link somewhere for the talk if you want to see more later. And here's the link for Cylc, cylc.github.io, which I used the wrong link. You can use cylc.org from the presentation of Hillary yesterday. And that's me. Thanks, Magda.
Thank you very much, Bruno. And if you want to post those links maybe in the discussion forum, Bruno, so that people can have a look at those, that would be really helpful. I'm
Sure.
just having a look in the portal now. There aren't any questions at the moment, but if you do think of something that you want to ask Bruno, please pop your questions in the live Q&A box, and we might be able to get back to those before the end of the session. But for now, I will move on to our next lightning talk speaker. Our next presenter is Nilani Algiriyage with traffic flow estimation based on deep learning using CCTV images. Welcome, Nilani.
Thanks, Megan. So I'll try to share my screen. Can you see my screen, Megan?
Yep, I can see it.
Yeah. Hello, everyone. I'm Nilani, and I'm a second-year PhD student at the Joint Center for Disaster Research, Massey University. The title of my presentation is Traffic Flow Estimation Based on Deep Learning for Emergency Traffic Management using CCTV Images. So during this presentation, I'll be going through just a part of an ongoing research that we are doing at the moment. First of all, I will just give you a bit of context. Emergency traffic management is one of the main problems in smart cities environments today. The causes of traffic emergencies can be small scale, such as vehicle crashes, or they can be large scale, such as earthquakes, tsunamis, or landslides. And they can also be planned, such as scheduled maintenance or unplanned. The traffic flow estimation is the first step in planning and managing these traffic emergencies. Traditionally, this was performed using underground inductive loops and pneumatic rod tubes, and there were other methods such as temporary manual counts. However, these methods cannot be used in large areas because of high cost, damages done to road surface, and difficulties in installation. As you know, today, CCTV systems are extremely common and mounted in many public areas to support real-time monitoring. The data generated by these CCTV cameras can be used as the foundation for accurate traffic flow estimation. The problem of traffic flow estimation can be defined as the number of vehicles during teeth time interval at the ith observation location in a transportation network. Therefore, in this research, we wanted to explore two research questions. First one is, what object detection algorithm is best suited for the image data set that we have collected? And the second one is, can traffic flow be estimated by counting the number of vehicles in each of these images? Therefore, we first pre-processed our image data set, and during experiment 1, we evaluated the performance and accuracy of 3 state-of-the-art object detection models, namely YOLO version 3, FastRCNN, and MassCNN, in terms of their speed and accuracy. And then we carried out the second experiment to formulate traffic flow by counting number of vehicles in each of these images based on the movement direction. We collected our data set from NZRSE, which is the New Zealand Transport Agency, through their traffic cameras API. And we had a particular location in Christchurch for this experiment. As you can see in the right hand side of the slide, there were images with this black background. These were created because of the faults in the cameras. Therefore, we had to pre-process to remove them. And then during experiment 1, we evaluated the accuracy and speed in detecting vehicles from our dataset during different times of the day. And we could see that YOLO version 3 was very fast in terms of identifying or detecting the vehicles, and it had a relatively high accuracy in detecting them. Therefore, we used YOLO version 3 as the algorithm to identify vehicles in the images, and we created a simple region of interest selection algorithm in order to formulate traffic flow based on their movement direction. And we wanted to eliminate, get rid of the parking area of the road. Therefore, with this algorithm, we came up with the traffic flow such as left lane and right lane. And we could obtain it as you can see here. So in conclusion, we created a challenging data set by collecting CCTV images through NZRSE Traffic Cameras API, and we evaluated the performance and accuracy of YOLO version 3, FastRCNN and MassCNN in detecting vehicles from our data set. And also we introduced a simple ROI algorithm to identify and formulate traffic flow based on the movement direction. As I said earlier, this is an ongoing project, and during the second stage, we extended our project to count the traffic flow, to count the number of vehicles from video footage at the same location. So in this part of the research, we are trying to classify the vehicles and also formulate the traffic flow. The specialty in this project is the video footage and the images we analyzed were very low quality. As you can see, this video footage is around 10 FPS, frames per second. So this can be extended to any location where there's a CCTV camera in the road network to obtain real-time traffic flow. So yeah, that's all about our project, and I'm happy to answer any quick questions. Thank you.
Fantastic, Nilani, thanks for that. And I don't have any questions at the moment. If you have questions for Nilani, make sure you pop them in the Q&A so I can ask them to her in right now in the session. I'll give you guys a few seconds to think about that. I did get a comment though in the discussion forum. Nick Young has done something similar to this, and he's shared a little link if you guys are curious what he has been working on.
Thank you very much for the comment.
Really neat. Thank you, Nilani. But yes, if you have any questions, pop them in the Q&A, and we might be able to get to those at the end of the session if we have a little bit of time. I will keep moving on then so we can get through all of our lightning talks. Our next presenters are my colleagues, Chris and Yuriy from NESI with Jupyter on NESI.
Thanks, Megan. I'll just share my screen. Hopefully you can see that okay. Yeah, so we're going to talk about Jupyter on NESI. So I'll give a quick introduction and then maybe talk about how it looks like for the user, and then I'll hand over to Yuriy, who's going to talk about Jupyter architecture. Yeah, so as has probably already been mentioned in a couple of talks already, NESI has recently released its Jupyter service for interactive supercomputing. We're currently going into the early access phase where researchers can get in touch with us to try it out and then give us feedback on how it looks like. We've had quite a lot of people from across NESI working on this for quite a long time now. So here's just a list of some of the people who've worked on getting this Jupyter service ready. The solution we've gone for is Jupyter Hub plus Jupyter Lab. And some of the use cases that we're seeing for Jupyter on NESI are the pretty standard Jupyter things like data analysis and visualization and machine learning. We saw a really nice demo yesterday from Massey about using Dask plus Slurm job queue with Jupyter notebooks to do machine learning work. Other use cases that could be used for interacting with a Slurm scheduler. So you can actually interact with Slurm through the notebooks, and maybe that's how you can go about having a reproducible workflow. If you wanted to run the same thing again, you could just rerun the notebook. Jupyter Lab also gives you terminal access, so it's an alternative to the usual SSH-based terminal access to the cluster. And Marko and I talked earlier about how you can also proxy and manage web apps running on the HPC through Jupyter. And this is what Jupyter Lab looks like to the user once you've logged in. So you can see we have the standard Python. We have a few different versions of Python and our kernels. These kernels correspond to environment modules that you get when you log into the cluster by SSH. So you can have the same environments whichever way you're coming into NESI. It's also easy. So we also pre-install a whole bunch of useful packages into these environments. So for most users, it's probably good enough just to use those. But it's also easy for users to add extra kernels of their own if they want. Say, for example, if they had a Conda environment, they could add a button of their own that would launch their Conda environment in the Jupyter notebook. So I think that's all for me, and I'll hand over to Yuriy.
Okay, so the requirements that we had for our custom Jupyter Hub instance is that we want the users to log in with their NESI credentials, including the second factor. So basic Jupyter Hub install supports spam authentication out of the box. However, it doesn't let you check anything other than the password. So we had to implement our own library for that. That library also requests a Kerberos ticket on user behalf that we will use later on. Another requirement is that the notebooks that run on user behalf will run on the NESI HPC cluster and will have access to the shared file system. However, we don't want the Jupyter Hub itself to have any access to the file systems in case it gets compromised. That's why, like, Jupyter Hub has the library called the bash spawner that knows how to talk to the various bash queuing systems, including Slurm, but it doesn't. It talks to it directly, whereas our instance doesn't have access to it. That's why we couldn't use it. We still used the source code from that as a template to develop our own spawner. Next slide, please. So this is the architecture that we implement. There is an intermediate host between the Jupyter Hub and the Slurm controller, and our own spawner will use the Kerberos ticket provided by the authenticator to SSH to that intermediate host on user's behalf, and then submit a Slurm job. This ensures that the user, the notebook will only access the resources using user credentials. So the challenges that we had is the port allocation, because once the notebook runs on the compute node, there can be multiple notebooks running on the same node, and every single user notebook will need an extra port. So at the moment, we just have a pool of ports that every spawner will request. what we want to do is we want the ports to be banished by Slurm somehow as a resource. Another challenge is the lifetime of the ticket, Kerberos ticket. It's a good thing that Kerberos tickets can expire. It means that the Jupyter Hub will only have access over limited periods of time. Unfortunately, this means that the hub can't call the notebook continuously. Once the ticket is expired, we have to assume that either the job is dead or the opposite, that the job is running, but you can't actually tell which one. And another challenge is the startup time, because it runs via the batch queuing system. We can't guarantee that it's going to start in a reasonable amount of time. The way we deal with it is we provide a progress page. Yeah, so that's the architecture. And if you guys are interested in trying out the Jupyter Hub, you can go to the links on the next slide and just register your interest. At the moment, it will only accept some users that are members of the early access group, but if you ask for, if you register your interest, you can get the access. Yeah, that's it for us.
Awesome. Thanks, guys. We do have a couple of questions that have come in. Eric mentioned that Jupyter Lab broke our notebook sharing via URLs. Do you guys have the same problem?
We haven't come across the same problem. I'm not sure exactly what that means, but we certainly haven't come across that yet, I think.
All right, awesome. If you want to clarify anything, Eric, we can do a follow-up question, but I'll move on to the second question that we had, which was, can you run RStudio server process alongside the notebook server?
We haven't actually got away. We haven't set that up easily for users to do, but it is possible. That I think there is an extension for Jupyter that allows you to launch an RStudio proxy, and there's no reason why a user couldn't do that. It's just we haven't actually tested it out yet and had people trying to do it, but it could be done.
Okay, and another one. How do you handle large data set access?
So because the notebook is running on the cluster, it has access to the project directories. If the user has to provide the data set via the web interface, it's going to take a very long time, but they can use grid FTP to transfer it in advance. It's one way.
All right. We have a couple more that have come in. Let's see. What happens if Jupyter Hub goes down? Their recommended setup appears to be based on Kubernetes to scale with multiple pods. And last I checked, the database of Jupyter Hub couldn't be shared by multiple instances, so you couldn't have 2 instances of Jupyter Hub using the same database for redundancy. Did you build something for working around that?
At the moment, no, we haven't started thinking about the redundancy at that level. So if the primary instance goes down, like we can probably have multiple instances running at the same time, but they will not be shared between users. So we'll just use sticky sessions to pin the individual user. So in that way, if one instance goes down, we can still have other instances running at the same time, but the database, of course, will not be shared. And the sessions that are started via that particular instance will be lost.
All right, one more question for now, and then we'll move to the next lightning talk. It is Cylc 8 uses Jupyter Hub to spawn Cylc UI servers instead of notebooks. Can you let us configure the hub to do that on NeSI?
We could definitely look into doing that. I don't know for sure whether it would work, but it would be good to look into it if it would be useful for you.
Fabulous, thank you guys. And we will move on to our last lightning talk of the session. It is going to come from Michelle Barker with FAIR for Research Software Working Group. Welcome, Michelle.
Thanks, Megan. Sorry, let me just share my screen. Right, I hope you can see that now. And I've also put a link to my slide set into the chat so that you can look at some of the links that I'll only talk to very briefly now in more detail if you're interested. I'm giving a talk today on behalf of a committee of people who are all mentioned there. And also on this call today, we have Paula Andrea Martinez and at this conference, so feel free to talk to either of us over the next few days if you have any questions. There's the copy of the slides again. What I'm going to be talking about is some work that we've initiated to apply the FAIR principles to research software. So many of you are probably aware of the FAIR principles, which at a high level are intended to apply to all research objects, but in practice have been applied extensively to research data, and you're probably aware of a number of efforts nationally and internationally on that. But we want to look at how we apply those to research software. There are some ways in which software is very similar to data and they can be applied quite easily. But there are also ways in which software is quite different to data and the FAIR principles don't easily translate. Our work builds on some other papers and workshop events that have been done over the last 12 months by a number of different groups. You can look at those yourself if you have more interest. So this group is called the FAIR for Research Software Working Group. I'll give you a link to join it at the end. It's jointly convened as an RDA working group, a Force 11 working group, and a Research Software Alliance task force. And I'm the director of the Research Software Alliance with the aim of defining and effectively applying the FAIR research principles to software. So by the middle of next year, we should have some principles that we've done extensive consultation with the community around, and then we'll begin to work with the community internationally on adoption of those principles. There's some more information on the timelines there, which is also on the website that I'll give you at the end if you joined up to our mailing list. For the moment, we've got 4 different subgroups running, looking at some different areas that will lead into the drafting of the actual principles. They started in July. Some of them are halfway through, some of them are still at an early stage. So you can still go to those links and join them if you're interested in contributing to this work. There's a complementary project that the Research Software Alliance is also running in conjunction with the FAIR for Research Software Working Group to start thinking about, once we have these principles, what are all the different pieces of work we're going to need to expound on them. If you think about all the different areas of work that's been done around the FAIR data principles, there's things such as indicators, maturity models, FAIR data services, curriculums, work on data management plans, etc. And we're going to need to do all of those for software. So we're beginning to engage with the community to understand where people are already doing work on FAIR for research software. There are already initiatives underway, or where people would really like to specialize in the development of one of these areas once the principles have been established. But feel free to contact us if you're involved in any initiatives around FAIR for research software already and would like to think about how we align our work to make sure that there's some synergies going forward. As I said, there's a copy of the slides again. You can join the group at that link. It's through an RDA, Research Data Alliance mailing list. So you just have to join RDA first, which is free. There's also some links there for some webinars we ran in July talking about the subgroup work when we were inviting people to join, so you can look at those. And our meeting minutes are also on a GitHub repo if you'd like more info. Very happy to answer any questions. Thank you.
Awesome. Thank you so much, Michelle. It's really great to have you presenting here today. And no questions have come through just yet, but I will give you guys a few more seconds to think of any questions, whether they're for Michelle or for Bruno, Nilani, or Chris and Yuriy. And while we wait on that, guys, I will just remind you that our final keynote session for NZRSE conference is coming up at 2:55 p.m. after a tea break. So you will not want to miss that one. It's going to be CSIRO's Dr. Dennis Bauer presenting that one. Okay, I think a question just came in. Let's see. Slides will be available after the conference, correct? Yes, that is correct. The slides will be available, although it will take a little bit of time for us to upload those to Figshare. But we will be reaching out to the presenters to get those presentation slides uploaded. Okay, so still waiting to see if there are any questions, but back to our keynote, which is happening at 2:55 p.m. The topic will be how computational science and data-driven health decisions help in the fight against COVID-19. Okay, still just keeping an eye out on the questions. And there was a follow-up question, clarification from Eric. His initial question was directed towards Chris and Yuriy about Jupyter Labs, about the sharing via URLs. He said user A wants to share notebook with user B, suppose that's the case. With classic notebooks, they used to simply copy the URL and share it, but with Jupyter Lab, they can't. So this might be something specific to plant and food, their setup, but worth checking on our end, perhaps.
Oh yeah, that makes more sense now, I guess. I haven't actually looked into that use case, but I have a feeling it probably wouldn't work for us either.
Yeah, I've just verified it. I've just looked at our interface, and it just shows the lab as a root URL. It doesn't have anything specific to the notebook, so I guess it is just a feature of the interface that you can share this way.
Okay. Sorry, did you say you were going to share a slide, Yuriy, or?
No. I just said that, yeah, I've verified it, and that seems to doesn't work for us, our setup either. So it's probably the feature of the interface rather than something specific.
Right. All right. Okay, and a question for Michelle. Fair for research software is a great thing. Wonder if that would help us bring more attention to software as research output rather than just publication.
Yes, certainly. That's the grand plan and the aim of all of those groups working together to promote the profile of research software as a first-class research output and other work done by those organisations. Obviously it's trying to bring together a number of different efforts in this area and get some synergies by getting some collaboration happening across them. So the more that we can bring together all the work that the research software community already does very well and represented in bigger and bigger forums and influence policy at national, international level and funders to help support the infrastructure, etc., then the more so we can all achieve that. So yes, it's very much part of our aim.
Great. And then a question for Nilani. Is your code open source?
Not yet. We are still exploring the things. So maybe we'll be able to host it in GitHub sooner, by the end of this year.
Cool, perfect. And then, so we are ending our session in 1:30 seconds. There is one more question I think we can get through from Jingbo. Michelle, any discussion or ideas on DOI for the software?
One of the areas that will have to be looked at is persistent identifiers for software, and there is of course some work already happening through organisations like Code Meta, and I think there's some other efforts perhaps in disciplines or nationally. As we roadmap who might work on what in the future, it would be great if we could identify A, who's already doing those things, B, who would like to be more involved in that conversation from later next year when we have the principles and are starting to think about adoption. So I should just add that one of the reasons that we really wanted to talk at the RSE conference is, of course, we see RSEs as a critical part of this conversation. So this is a heads up that we'll be doing lots more consultation next year and hoping to work with organisations like the New Zealand RSE Society to coordinate that. So there'll be lots of opportunities for people to contribute all through next year.
Thanks so much. So we're ending in 20 seconds. I'll give a big thank you to our Lightning Talk presenters for sharing today. We will now have a 20-minute tea break, and I will see you guys at 2:55 p.m. for our final keynote session. See you guys.